I became intrigued by some comments from a viewer who had watched the restoration of this B&K 650, including the addition of this 610 test panel. And the question that he asked, well, actually the first question he asked had to do with a different issue, which I'll get to in a minute. But one of the questions that he asked was whether it was possible to test an EL84 on the 650 without buying the 610 test panel. In other words, what he had in mind is to use one of the spare sockets. Well, here is the EL84, and as you see, it's a 9-pin beam pentode. So one of the things I did was go to a substitution guide looking for an EL84, and I found one here that says a 6BQ5 is a substitute. So the next thing I did was get the 6BQ5 data out of a tube manual and look to make sure, for example, that the pinout was the same and that roughly the electrical characteristics were the same. Having satisfied myself that the 6BQ5 was a decent replacement, it turns out the tube guide says it's an excellent one. I then tried to determine if you could test the 6BQ5. And it turns out that you can. Right there is the settings, and you notice it says that it uses heater 6 and the socket is 610. What it means by that is it uses the 9-pin socket on the 610 panel, and it uses those settings that you see to the right, 57, 4, 9, 725, 3025, 25, 1. Now, we'll talk a little more about those in a minute, because having done that, I decided to see whether, in fact, the EL84 and the 6BQ5 are treated similarly. So I went to the 707, the B&K 707 tube guide, and I found that it tests an EL84 in socket 23 with a sensitivity of 68. I then looked to see how it tests a 6BQ5, and it's identical. Heater 6, socket 23, sensitivity 68. So I was then satisfied that, okay, if I can set up to test a 6BQ5 on a 650 without the 610 test panel, then you can also test an EL84 the same way. So then the question became, well, how do you do that? And as they say, therein lies a tale. Because I learned a lot about the 610 in researching this. Probably over-researching it, but then I admitted in a previous video that I'm probably compulsive when it comes to this vintage test gear. So I had a lot of fun, and I think I now can give some answers. So let me set up to show what I would suggest that somebody do in a case like this. However, I will emphasize that what I'm about to show you will work for just about any new tube that you find that you can't test on a 650, but you would like to wire up a special socket to test it. Maybe it's your favorite guitar amp tube or your favorite hi-fi amp tube or preamp tube or whatever. Anyway, so let me set up to show you that. First, on a 650, there are a number of empty tube sockets. These are a bunch of 9-pin tube sockets, and 3 more up here, that are unwired. Those are shown up on that panel on the right. You see this entire row and this entire row up to there are unused. So any one of those could be wired to test an EL84. The question then is, how do you wire that up? And to understand that, you have to come back down and look at the way that a tube is wired up. There you see a series of lines, and the only way you can tell where those lines go is to literally trace them through until you get back to the signals that you see over here. For example, high bias, medium bias, low bias, and zero bias, heater, and so on. So you need to figure out which of those pins to wire to which pins, which of those signals to wire to which pins. Now, let's take a look at a 610 and how it is put together. Those of you that have watched the other B&K tester restorations will know that all of the B&Ks of this vintage, the 500, the 650, the 700, 707, all have a large connector in the center, and there are a series of signals coming off of there. A 610 is connected by wiring in a special octal socket to a certain set of those signals. Then you plug the 610 into that socket. So here are the signals that are being brought out to that connector. You see high voltage rectifier, you see a heater here, and up there you see another heater winding or wire coming down. You see a high bias signal, you see a GM1 signal, you see a zero bias signal, and then you see a wire here that says to another socket, and we'll talk about that one in a second. Basically, what this amounts to is there is a bias signal that is derived between the high and low bias. There is a pair of heater connections. There is the GM1 wire, that is the wire on which you measure the mutual conductance. This is the plug. On the socket side is the 650, and on the 610 side is this plug that plugs in. This is the 8-pin plug. And you can see that it has a number of signals. One of the ones that I found most interesting is this one that comes up to that 20K pot. And you may notice that it's labeled here H. That is one of the controls, and it's connected between zero bias and high bias on this 8-pin plug. What that means is that unlike the 650, where the bias can only be set to high, medium, low, or zero, here you can set it to any value between zero and high bias. That's one of the weaknesses of the 650, is that it uses bias values that are often inappropriate for a particular tube, and in a little bit I'll show you a situation where it really can confuse people. But nonetheless, this is a plus of having the 610. Now that's a 20K linear pot, so at mid-range it's 10K. That is used to provide the bias. Other than that, all of the signals just get carried through. But they get carried through in a little bit unique way. You notice this set of switches up here. Those are the rotary switches, and they have various functions which I have written up at the top. You see that switch on the left is for heater, then GM1, then another heater switch, and 2 ground switches. This switch is the bias switch, which comes to this pot. And this switch comes down to a special multi-purpose selector here, which we'll talk about in a second. So basically what those switches do is they simply connect signals over to various pins of these sockets. So here is the 9-pin socket. If you think about this for a minute, all the 610 is doing is basically wiring a set of these pins to signals in the 650. And so the question then is, well, how do you determine which signals to use? You determine which signals to use by using the settings for the 610. Remember, we said the 6BQ5 is a direct replacement for the EL84. The sensitivity of 57, and it goes in the 610 socket, which means that you plug it in to the 9-pin socket right there, and then you set these switches, which are labeled, you see there, A, B, C, D, and then the next row is E, F, G, and what those effectively do is wire the 6BQ5 to the right pins or the right signals inside the 650. So A is pin 4. That means pin 4 on the 9-pin socket is connected to the A signal, which the A signal is the heater signal. Remember, we talked about this. That's the A switch. And then this is the B switch. So how is that connected? Well, the B switch is set to pin 9. That's the special selector. The special selector chooses between 4 functions. However, we will see that the function used for the 6BQ5, which is so the selector of J, that is switch J, is number 1, which is the GM position. GM. So once again, we have 4, 9, then C is connected to 7. Look back here. A, B, C, D, E is the other heater. So A, B, C, D, E. So the heater is from 4 to 5. Pin 9 is connected to that special purpose switch. 7 is switch C. 2 is switch D. Switch F is set to 3. And switch G is set to 0. That's basically ground. Then H, which is the bias setting, I'll show you that in a second, is set to 25, and J is set to 1. So what does that mean? Well, let me set up to show you on the 610 panel. So the way you would set up for a 6BQ5 is to set A to 4, B to 9, C to 7, D to 8, E to 5, F to 3, G to 0, and then you would set H to 25. Now notice that H is calibrated from 0 to 100. And as I said, it's linear. So in other words, if you set this to 50, that means that you are biasing the two halfway between the 0 bias and the high bias. Well, zero bias is basically 0 volts, and high bias is whatever it's set to. I believe it's about minus 18 or 19 volts. So at 50%, you would be setting the bias to about half the way between those two. At 25, you're setting it to 25% of the way. In other words, to 25% of 18 volts. And then finally, over here is switch J. And you'll notice it says switch J should be in position 1, which is GM. The other positions are rectifier, diode, and high voltage rectifier. That selects what kind of circuit is being used to measure GM. Then you do everything else as you would in a normal test. That is, you set the sensitivity to 57 and you put the 650 into the test 1 position there. There's the sensitivity control, and of course the heater is set to 6. So how would you go about doing that in a 650 without the 610 test panel? I would suggest that once you've chosen a particular socket, this is just arbitrary, has to be a 9-pin of course, that you wire it up, the heaters to 4 and 5, the others as we talked about, that is the signals the same as would be connected in the 610 panel, except when you get to the bias. When you get to the bias, what I would do is I would put a divider. In this case, you could use a pot if you wanted to have something that you could vary, or you could simply put in 2 resistors. Let's suppose you put a 25K, a 5K and a 15K. That would give you 25%. And then a 22K resistor, I used 5 and 15 because that adds up to the 20K that's in this pot. And then a 22K resistor to the bias pin. That will provide you with the same bias. Now that socket, the one you wired up that way, will work just like any other socket on a 650. You don't need the 610. Okay, I hope that is useful for that part. But let me talk about a second issue that the same viewer brought up. He was testing a 12A T7 and a 12A X7. Well, what he found out was that the 12A T7 tested normally, if I remember right, and the 12A X7 did not. So first let's look at what the tube selector manual for B&K says about that. For the 12A T7, you see it shows you the 12 volt heater, socket 50, and a sensitivity of, I think that's 86. So that tests normally. Now let's look at a 12A X7. Here is a 12A X7. Once again, 12 volts, same socket, 50. Sensitivity of 91. But then notice it shows 2 tests, 91 for both of them, and it's then an asterisk that says too good if reads 1200. Well, 1200 on the meter is right in the middle of the replace range. It's down around here. So if it were not for the little cryptic comment about 2 tests good if reads 1200, the ordinary person, if they set sensitivity of 91 and ran test 1 and test 2, Both would say replace, they throw the tube away, but it's perfectly good. Reached 1200. So why did that occur? Well, the reason is that because in this tester, B&K only has 3 bias values to choose from, and they chose to use the same bias value for both tubes. With 300 volts and minus 3 volts of bias, you get a little under 10 milliamperes of current. Now, if you look at the 12AX7, and by the way, to find the plate characteristics of the 12AX7, you have to actually look under the 6AV6. Consult the tube manual and they'll explain. These are equivalent, the only difference being the filament voltage. So, this one at 300 volts and minus 3 produces about 0.5 milliampere. In other words, one produces nearly 10 milliamps and the other produces half a milliamp. That's the reason why it only goes to 1200 on the meter. Now, why did I bring that up? Because I think B&K realized that that was a poor design choice. And that's why on the 610 they put this bias pot. I believe you will find that if you really want to set the bias for a particular tube to the correct value, you might want to consider adding a potentiometer like this to the bias circuitry of the 650. Now, it's already there in the 610. But if you're testing the tube up on the other panels, that is this panel on the left here or the main panel on the right, you're stuck with still the 3 bias levels. I'm considering putting a potentiometer in mine so that I can set the bias to exactly where I want, or more appropriately, where the tube manufacturer recommends you test the tube. So I hope that this has been helpful and that it might inspire a few people either to do a 650 restoration or perhaps add a 610 panel, or as this other viewer is planning to do, wire up a socket or two for their favorite tubes using the lessons learned from the 610. Once again, I hope you enjoyed this and you'll stay tuned for some future videos.